Alrighty, so today we're going to be looking at Unit 4, notes number 10. Okay, and it's our last set of notes for Unit 4, so congrats, we made it. Okay, so our goal today is that we will be able to apply a scale change to a function. So we're going to be applying lots of scale changes to a lot of different types of functions, but of course we're starting with linear because it's our linear unit. Okay, so first, what exactly is a scale change? What am I talking about when I say we're going to apply a scale change? So a scale change changes the entire function. It doesn't just change a part, like a transformation changes a part of the function. A scale change changes the entire function. Okay, so it changes everything about the function. So, for example, okay, a scale change might double the function. So if we apply a scale change of a 2, we multiply everything by a 2. Okay, so that's going to double the entire function. Another example might be that we're going to half a function. Okay, so if I apply a scale change of 1/2, we're going to take half of the entire function. So I'm going to half a function. Okay, so we're going to deal with mostly actually those two for our notes today. What happens when we double a function and half a function? So if we jump right in, look at our first example. It says you're given the function f of x equals 2x minus 4. This is my function. And so we're going to write the equation of y equals 1/2 of f of x plus 3. Guys, this right here is my scale change. So let's look at what we're actually doing in this scale change. Okay, so in this scale change, we're applying the 1/2, which means we're going to half the entire function, and then we're going to add 3 to it. Okay, so that's the scale change that we're going to be applying here. So to do this, we're going to take our entire function, the 2x minus 4, and plug it in for the f of x. Okay, because f of x, those match, so we're going to plug it in and apply our scale change. So we're going to have y equals 1/2. Instead of f of x, it becomes, 2x minus 4, and then plus 3, because we're going to apply that scale change. So now, anytime we have something in front of the parentheses, we're going to distribute. So half of 2 gives me 1x, and half of negative 4 gives me negative 2, and I just bring down the plus 3. So now we just need to combine our like terms. So we're going to have y is equal to 1x, negative 2 plus 3 gives me plus 1. So this is my new function after the scale change. Okay, so that's my new function. Awesome, cool, that's great. Okay, so now we're going to graph your function from part A. Okay, so we're going to have, this is in slope-intercept form, so my slope is 1. My b value is a 1, so that means my y-intercept is 0, 1. So we're going to graph that. So we're going to go over here to 0, 1, plot a point. My slope was 1, so I'm going to go up 1 and over 1, 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 so on and so forth. And we're going to connect the points and be good to go. So then part C, so this is my new function. Okay. So it says which of the following is true when the scale change, so this is my scale change, is performed on the function f of x equals 2x minus 4. So this was my old one. Remember, our new one was y equals 1x plus 1. Okay, so we're going to compare the two. What changed? Well, the first one, because I want to know what's true. The first one says the resulting function is shifted down 4 units. Well, if I look at this, my y-intercept was negative 4, and then it became a 1. So how do I go from negative 4 to 1? I added 5. So that means it was shifted up 5. It wasn't shifted down anything. Okay, so I know that this is not true. The next one says the resulting function is shifted up 5 units. Well, hey, we just said that. Awesome. I love it when I answer my own questions. Okay, so we just said that it had to go from negative 4 to 1, so it shifted up 5. So that means this has to be true, the resulting function is shifted up 5 units. Let's check the next two just to make sure they're good. It says the resulting function has the same slope. Well, this was a slope of 2, now it became a slope of 1, so obviously that's not true. And the next one says the resulting function has the same y-intercept. Well, we went from a -4 to a 1, so obviously that's not true either. Alrighty. If you have any questions about the first one, please make sure you're asking. Looking at number 2, it says this is the graph of f of x. So we're going to start by writing the equation of f of x. Okay, so I want everybody labeling the graph f of x. And we're going to start by writing the equation of f of x. So to write the equation, we need to start with our b value and our slope. So my y-intercept here is 0, -1, which makes this my b value. So I know my b value is going to be a 1, or -1, my bad. Now I need to find my slope. Well, if I look at this, for slope, I check the rise over the run. So I find 2 good points. I rise 1, and I run 1, 2, 3, 4. So that means my rise was 1, my run was 4. So that means my slope is going to be 1/4. So to write the equation, I just need to plug all those in. We said that this is f of x, so we're going to have f of x is equal to, my slope was 1/4, so 1/4 x. My y-intercept was at -1, so -1. All right, so we wrote the equation. Sweet. The next one says write the equation of the scale change y equals 2 f of x plus 3. Okay, so that means we're applying a scale change of a 2. That means we're doubling the entire function. Okay, so I'm going to take this 1/4 x minus 1 and plug it in for the f of x. So I'll have 2, and then 1/4 x minus 1 plus 3, because that's the scale change I'm performing. So anytime we have something or a number in front of parentheses, we have to distribute. So 2 times 1/4, well, 2/4 give me a half x, and 2 times -1 gives me -2 plus 3. We're going to combine our like terms. So I have 1/2 x. -2 plus 3 gives me plus 1. So this was my new function. After the scale change, this is new. And now it says to graph my function from part B. So I got to graph my new function. So my y-intercept is 0, 1. So I plot a point. My slope is 1/2, so I'm going to go up 1 and over 2. Up 1 and over 2. Up 1 and over 2. And connect. Alrighty. If you guys have any questions about the first page, let me know. Okay, let's move over to the back. Okay, so we're going to do one more of these scale changes where we have to start by writing the function. Okay, these are by far the trickier of the two. Okay, so we got to make sure we're practicing those. So this says write the equation of f of x. Okay, this is our graph, so we're going to label it f of x, just so we know. And we're going to write the equation. So we need to start by finding our slope and our y-intercept. Okay, so our y-intercept is here at 0, 1. So that means my b value is going to be a 1. Write that down so we don't forget. And then I need to find my slope. Well, the first thing I notice is that my line is going down. Since my line is going down, that means I know my slope has to be negative. So we're going to find 2 good points. 1, 2. So I got to check my rise. Well, I'm going down, so it's going down 1, 2, so -2. And I ran 1. So I know my slope was -2 over 1, which reduces to -2. Always make sure you reduce the slope. So now I can write the equation. So it's f of x is equal to, my slope was -2 x, my y-intercept was 0, 1, so plus 1. So now we're actually going to find our scale change. So write the equation of the scale change at y equals negative. So remember, that's like having a negative 1 out front. So negative f of x minus 3. So we're going to take our entire function, plug it in for the f of x. So y is equal to negative 1. Instead of f of x, it becomes negative 2x plus 1. And then I bring down the minus 3. So I got to distribute that negative 1. So negative 1 times negative 2 gives me a positive 2x. And negative 1 times 1 gives me negative 1 minus 3. So I'm going to combine my like terms. Now I have y is equal to 2x. Negative 1 minus 3 gives me negative 4. So last but not least, it says to graph the function from part B. So I start at negative 4. My slope was a positive 2, so I'm going to go up 2 and over 1. Up 2 and over 1. Don't mind all my extra writing. Alrighty, if you have any questions about the scale changes, please make sure you're asking me. Alright, looking at number 4. Okay, so number 4 says, which of the following is true when the scale change y equals 2 f of x is performed on the function y equals half of x minus 3. So we haven't actually done the scale change. We don't have any graphs to look at. Okay, so we're just going to perform the scale change really quickly. So to perform our scale change, we're going to take our function and plug it in. So I have y is equal to 2. Instead of f of x, it becomes 1/2 x minus 3. And all we have to do is distribute the 2. So I'll have 2 times a half. Well, half of a 2 gives me 1x. And 2 times negative 3 gives me negative 6. So this is my new function. I'm going to write it over here just so it's easier to compare. This is old, new. Okay, so now we're going to figure out which one of these is true. So the first one says the resulting function is shifted down 3 units. Well, if I look at this, I went from negative 3 to negative 6. Well, how did I go from negative 3 to negative 6? I subtracted 3, so I went down 3 units. Well, that right there is our first option. Normally, I don't mean to make it the first one, but I did today, so that's okay. Let's just check the other ones just to make sure. It said it's shifted up 2. Well, we just said that it went down 3, so we know that's not true. The function has the same slope. This has a slope of 1/2 and a slope of 1, so that one can't be true. And then it has the same y-intercept. We went from negative 3 to negative 6, so that's obviously not true either. So the first one was our answer. Nice. Alrighty. Okay, let's do a few review problems and then we will be done for the day. So this one says graph the following inequalities. So we got y plus x is less than 4. Since we have less than, we know that that's going to be a dashed line. Since it's less than, we know it's going to be dashed, which is totally okay. From here, we're going to solve for y just to make it a little easier to graph. So I'm going to subtract the x over. I'll have y is less than negative x plus 4. So it's in slope-intercept form. So this is my b value and my slope. So I'm going to start at 4. And we just said my slope was a negative 1, so I'm going to go down 1 and over 1. Down 1 and over 1. Okay, and we're going to connect. Oops, that line was even worse. Maybe. There we go. Oh, but I just realized I worked so hard to get that line and I didn't dash it. Hopefully you remembered to dash it. If not, hopefully you weren't writing in pen. There we go. Okay, so now we need a graph. We need to check our test point, or we need a shade. We need to check our test point, which is 0, 0. So we're going to plug that in. So this is our test. Okay, so I'm going to have 0 is less than negative. Instead of x, it becomes a 0, 2 plus 4. I'm just going to simplify, and I'll have 0 is less than 0 plus 4 gives me 4. Well, 0 is less than 4. That's true. Awesome. So I'm actually going to shade our true side. So that means this is our solutions. So it's shaded, and then we're going to actually label it solutions. Smiley face. There we go. Alrighty. Let's do the next one. We have y is greater than 2. This is just y and a number, so it's our HOI. So that means it's going to be a horizontal number or horizontal line. We also know that it's greater than, so that means it's going to be dashed again. If it was greater than or equal to, it would have been solid. So we're going to go to the y-axis, and we're going to put a point on 2. And we just said it's going to be the horizontal line, so make sure you dash it. And I want everything that's greater than 2. Okay, I want all the numbers greater than 2. Well, 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, 6 is greater than 2. So that means we're going to shade all those numbers because they're all greater than. And that's going to make this our solutions. All right. So a few extra questions. The first one says, is the point 0, -1 a solution? Yes, it is in the shaded area. And then the last one is 3, 2 a solution. Well, if we plot 3, 2, it's actually on our dashed line. So this one's actually a no. Okay, because it's on the dashed line. Alrighty. We're going to quickly do the last one. Okay, pretty short, sweet, and to the point. It says write the equation for the function with a y-intercept of 3. So that means this is our b value. And a slope of -2, that's our m. Okay, so since I gave you the y-intercept and the slope, we're just going to plug them into slope-intercept form. So we'll have y is equal to, it's mx plus b in case we forgot. That is an x, not a weird looking v or y. So y is equal to, my slope we said was -2, I think. Yep. So -2x plus 3. Alrighty, if you have any questions, please make sure you're asking. If not, you can move on to your homework.